All right.
How many valence electrons do the main group elements have? Safety group and number of valence electrons for that group.
Yes, group 1 has 1 valence electron. Group 1 has 1, that's correct. What about group 2? 2. Then we're going to go over 13 through 18. Does anybody remember what you got to do with those to figure out how many electrons? Valence electrons. Subtract 10, Crystal, that's correct.
I think that was from
So group 13 would have 3, 14, 4, and so forth and so on, until we get to 18, which would have 8. A nice octet that makes them very stable. All right. And you're going to see, we're going to talk about ions today. So those are the notes. We're taking a little break from the notes that we have been doing, and we're going to do the notes on ions because they're going to be kind of important before we do the trends. This is your schedule this week. You only have 1 quiz over ions, which we're learning today, and that will be on Thursday. I'm going to have a sub on Friday, and so I'm not for sure if y'all will Zoom or if it'll just be doing your work online, but I'll find that out to let you know between now and then. Last day to requiz, so molar mass is the last day to requiz is today. The periodic intro quiz, which y'all had on Friday, the last day to requiz on that is this Wednesday, and then the ion quiz, which we aren't taking till this week, that'll go back into next week. If you need to retest, you're going to need to let me know that you're coming in to retest or that you're going to Zoom in to retest. It's a completely different test, and there's no open notes on that. If you're going to turn in if you're going to do a scientist to try to get those extra 5 points, the last day to turn in that paper is on Thursday, the 15th by 3 p.m., not sometimes late into the evening. I only have gotten 1 from Aaron. I had Rodney ask me about somebody, but Rodney, you never turned in the paper. So at this point, I don't have you down for that. You'll need to fill out the paper and turn that in. If you do not turn in the paper that reserves it for you, then and you turn in and then you do the assignment or you do the little project, you will not get credit for that project. Tutorials are today and tomorrow after school, and I have several in this particular class that have already let me know that they're coming today. So I will have that open for y'all. I have it set on my alarm to go off about 3:37. Does anybody have any questions over any of that stuff?
Yes, ma'am.
Yes, sir.
On the molar mass quiz from last week, the actual format didn't let us put the
units, but Franklin, I didn't take off for that. I didn't take off for that, so I only looked at the number part of it. And I'm just trying to remember, but I don't think that you rounded yours 2 places past the decimal. I think maybe you had some that went a little bit more past the decimal.
Okay, because I asked some friends too, and they all said that they all got zeros on it too.
Yeah, there were quite a few zeros on it because quite a few people did it incorrectly, but it had nothing to do with the units. That was not why people got zeros on those. But thank you for checking.
Okay.
But yeah, that's not why you got a 0. You got a 0 because either you either rounded incorrectly, which would have given you the wrong answer, or you didn't do 2 places past the decimal, which there was quite a few of those that just put whole numbers or went 3 or 4 places past the decimal. So those would have also been incorrect. What I keep referring to as far as what needs to be turned in for your little project is if you go under announcements, I think this is in a couple of places, but maybe under daily work. Yeah, daily work, dead chemist.
I got the question for you.
Just 1 second, I'm showing them something. This very last page is what has to be sent in and emailed back to me, okay? And that has to be done before you're able to have a chemist to do your work on. Yes, sir.
I'm trying. I know the chemist I'm looking for, but the problem is that the Chromebooks block it. They think it's some mad thing. More reality, he is the person who discovered the element vanadium, element number 23.
Well, do you have something besides your Chromebook you could work on it at home with?
My phone. Yeah, my phone. That's the only electronic I have. Also, my Wii, which also has an internet browser, but it's very outdated.
Yeah, because I can't get just one little thing unblocked. I don't have the power to do that, Angel. I'm sorry.
It's okay.
Alrighty, if you will go to your notes. It's the ones that say ions. We're going to talk about that for a little bit. All right, we've talked about ions before. Ions are atoms that have either lost or gained electrons, so now they have a charge. Anything on the periodic table, that's an element, that's an atom, and it does not have a charge. So if I look at magnesium, this is an atom. My protons are equal to my electrons, so they cancel each other out. But once magnesium forms an ion, it loses 2 electrons. And now my protons are not equal to my electrons. In this case, for magnesium, and it won't always be this way, but in this case for a metal, you have now more protons than you do electrons, and now you have a charge. So this is an ion.
I can't see that. It was too bright.
Too bright? Let me turn one down here and I'll change to a different color. That may help a little bit, Angel. All right, so when an atom or a molecule gains or loses an electron, it becomes an ion. A cation has lost electrons. And therefore has a positive charge. I think of cation, I think of that T as a plus sign. That way it helps me to keep it from the other word that means a negative charge. So this is what our metals do. So magnesium, if you would correct this, it should be minus 2 electrons, not plus 2 electrons, little typo there. Is going to end up giving me my magnesium 2+ ion. Now I have 2 more protons than I do electrons. And that's why I have the charge. An anion has gained an electron, and therefore it has a negative charge. And this happens to non-metals. So non-metals have a valence of electrons that is closer to 8. Remember, an 8, like the noble gases, that gives stability. So non-metals are going to gain electrons, and they're going to try to get to that full octet. So this would be an element or an atom with no charge. And then this would be the ion of nitrogen. This would be my nitride ion. We talked about naming those before. If it's a negative ion, you have to change the ending to "ide." You can put the word ion, but you don't have to. If it's a metal cation, then you keep the name the same and you add the word ion to it. So to tell the difference between an atom and an ion, it would either be by its name or by the fact that you would have to look at it, see if it has a charge as a superscript. So once again, magnesium like this is just a neutral atom. Magnesium with a 2+ is an ion. Sometimes it may be represented with the nuclear notation. The nuclear notation is the one that has the symbol and then it has the atomic number and the mass number. If it's an ion, it still has to have that 2+ charge to show that it's that ion. Remember, when it's an ion, it's just forming, it's just changing the electrons. So it doesn't affect the atomic number and it doesn't affect the mass number. All right, which of these are ions? Just to be an ion, all that means that is that it has to have a charge. So that would mean any of these at the top, those are all ions because they all have a charge, whether it's positive or negative. If I put a check over the ones that are anions are negative. So that's going to be my iodide and my oxide. I can put an X over the ones that are cations. That T tells me those are positive. So that would be my sodium and my calcium. And if you look, the ones that are positive are metals. The ones that are negative are going to be my nonmetals. And then all the rest of those would just be my elements because they don't have a charge. On all of those, my protons are equal to my electrons. Now, why do they gain or lose electrons? They do it for stability issues. An element gains or loses an electron to get a stable octet. That octet is 8 valence electrons. Like the noble gases, with the exception of helium, but helium is stable with just 2 valence electrons. So it wants 8 electrons in its outermost shell. Increased stability leads to a lower energy level. In the elements, the ions want to exist at the lowest possible energy level. So there's a couple of different ways to predict what kind of ion may be formed.
Yeah.
So we're going to start off. I'm sorry? Did I hurt somebody? My imagination?
I heard it too.
Okay. All right. So magnesium is in group 2. So it has 2 valence electrons. It has a total of 12 total electrons. So since our noble gases are stable, that's what an element or an atom would like to get to. So you look at the noble gas that is closest to magnesium. It could be behind it or it could be in front of it. So if I look at my periodic table, magnesium is element number 12. So my choices are argon, which goes all the way up to 18. Or the noble gas before it is neon, which is 10. So 10 is a lot closer to 12. So my closest noble gas is going to be neon. And it has 10 total electrons. So then you look, what does magnesium need to do so it can be like neon? Because that's what increase its stability. And you can see it needs to lose 2 electrons. And that is how many valence electrons it has. That's not by coincidence. So it's going to lose those 2 valence electrons. And it will become isoelectric, ISOELECTRIC. It'll become isoelectric with neon, which means it has the same number of electrons. It doesn't have the same number of protons or neutrons because those 2 subatomic particles haven't changed, just electrons. So it's changed its configuration, electron configuration, by losing 2 valence electrons, and then it'll be able to fall down to its other orbital, which is full with an octet. So we said for magnesium, it needs to lose 2 electrons, so it will have an octet. And whenever it does that, it goes from Mg neutral, because now my protons and electrons are no longer equal, to +2. If the element loses electrons, it becomes a positive ion because it's losing something negative, and this is what metals do. So as we predicted, it would become an Mg2+. And in fact, anything in group 2, because it has 2 valence electrons, will lose those 2 valence electrons and become a +2 ion. If we go to the other side, so now I'm going to the non-metal side, I have fluorine. And fluorine it's a halogen, so it has 7 valence electrons. It has 9 total electrons. It's element number 9, so the closest noble gas to it is neon, because neon is element number 10. So once again, my closest noble gas is neon, which has 10 total electrons. So once again, fluorine wants to get isoelectric with neon because neon has a stable electron configuration. It has 10 electrons. It has 9 electrons. Neon has 10. So what does it need to do? Yes, it needs to gain 1 electron. So when it gains 1 electron, it'll go from being neutral to having a -1 charge. So if the atom gains electrons, it becomes negative. And this is what non metals do. And if you notice, we said that fluorine had 7 valence electrons, so if it gained one more, which is what it did, it goes up to 8 valence electrons, a full octet, which is going to make it very stable. So we said fluorine, which is a non-metal, it's closer to 8 than it is. So it will gain electrons to get to that noble gas notation. And that will have my fluorine, my F -1. This, if you put just a minus, it's an assumed one, kind of like a subscript. So F -1 is the same thing as just F minus. Or if it was a plus, potassium forms a +1 or potassium plus. All right, so there are some patterns that are followed that are pretty easy to look at when you look at the periodic table. I'm going to add right here aluminum, or actually group 13. They always form a +3 ion, anything in group 13. So group 1, which we said has only 1 valence electron, they're always going to form +1 ions. Group 2 that has 2 valence electrons will always form +2 ions because they want to get rid of those valence electrons. Group 13, which has 3 valence electrons, will always form +3 ions. Group 14, which has 4, is kind of in the middle, so it doesn't really tend to form an ion. It more likely is going to form a covalent compound where it shares electrons. Now, when we start getting on this side, groups 15, 16, and 17, they have either 5, 6, or 7 valence electrons. That's closer to 8. So instead of losing a bunch of electrons, they're going to gain them to try to get to that octet. So group 15 has 5. It needs to gain 3 more, so it becomes a -3 ion. Group 16 has 6 valence electrons, so it needs to gain, it has a -2. Group 17, 7 valence electrons, it only needs to gain 1. So those all form -1 ions. What about the noble gases? What kind of ions were they formed? Do y'all think the noble gases will form any ions? Do they want to lose or gain electrons to get stable? No. Noble gases will be no ions. They don't want they already have their stable octet. They don't want to lose or gain ions. Lose or gain electrons. So they will not form ions. Oh, sorry about that, y'all. There's one more of those noises coming in a minute. Like a little magic trick. All right. So got a big picture. In general, metals are going to lose electrons, become positive ions. Non-metals, so that's going to be 15, 16, and 17. Those are going to gain electrons and become anions, negative ions. All right, so how would you write the ion for sodium? What would it become? It's from group 1. That's right, Na plus. Because everything in group 1 loses 1 electron. Now, we haven't talked about our transition metals because they don't follow all the rules. I can't say everything in group 3 has 3 valence electrons. And in fact, some transition metals may have more than one charge. So an example would be iron, Fe. I'm going to come up here. Sometimes iron will lose 2 electrons and be a +2 ion. Sometimes iron will lose 3 electrons and be a +3 ion. It's still a metal, so it's still losing, it's still forming a cation. The way that you would know the difference with this, if you saw its symbol or if you saw its name, is you would see Fe, and then in parentheses, there would be a Roman numeral 2. That Roman numeral tells you the charge of that particular transition metal. This one would be Roman numeral 3. That 3 tells you that it's the +3 ion. Don't have to do that for the main group elements because they are not going to form 2 different kinds of ions. They only form 1 ion, but the transition, some of them can form 2 different types. Some of them even 3. So there's got to be this Roman numeral notation that tells you which one is formed. All right. All right. So let's look into our Google Classroom in a minute. First of all, I'm going to go to my regular chemistry because I'm recording, and then I'll come to ours. So if you have second period regular chemistry, here you're going to go down to your daily work, atoms and ion work. So you'll have to use Cami to do that worksheet and turn it in. For all my other honors, we're going to look at that one. So this is practice. You'll have a quiz on Thursday, so you have your answers with it like you do for practice. All right, so ion practice, we'll just look at a couple. All right. All right, so you're given the element, and then you're saying what kind of ion it would form. So bromine is a halogen, so its symbol is Br. So it's a halogen that has 7 valence electrons. So what kind of ion is it going to form? If it's a halogen in group 17, it has 7 valence electrons. It wants to gain 1 more. So it would become a -1. And it would be bromide. And you don't have to, but you could put ion. And if we came down and we looked at a metal is going to form a positive, not a negative. So lithium is Li in group 1. So it has 1 valence electron. It's going to lose that 1 valence electron and become Li plus 1. And it would be lithium ion.
They use that in batteries.
Yes. The second page is pretty much the same, although it does have some transition metals in it. So notice any of these that have these little parentheses, those are transition metals. But that actually makes it easier. I don't have, if I have a parentheses with the Roman numeral, I don't even have to look at the periodic table because this right here is telling me what the charge is. Fe is for iron, and since it has a 3, it is a +3. And then we know it's a metal. So it forms a cation. So that's what your practice is on. So your quiz on Thursday will have some like the practice, and then there'll be some other ones off of your notes and talking about gaining and losing electrons. So y'all got about a little over 5 minutes to work on some practice if y'all want to. If you have any notes, you can unmute. I'm sorry, any questions, you can unmute and let me know what they are.
Miss Lowry,
Yes.
can I come
Yes, ma'am.
or get on the tutorial Zoom to retake the test for molar mass?
Yes. After school?
Yes, ma'am.
Today, yes. Yeah, I opened up. I have my alarm set about 3:37 because even though the bell rings here at 3:30, I don't know if y'all know it or not, but we're like on a staggered release. Like I have to release the first set of students that are on the bus and then wait. So about 3:37, I'll have that Zoom open. Okay.
Yes, ma'am.